All right, so we're going to be talking about some more financial math when we're talking about loans and savings. So we obviously have talked about compound interest and things like that, but there's slightly different small changes in the amount that things are worth when you're doing things like putting in $50 every single month versus what we've kind of been talking about before, where you put in a big lump sum and figure out what's going to happen over time. So, for example, here in number 1, we're looking at you put in $50 in a savings account with 2% interest compounded monthly. That would be a compound interest problem. Now, let's add in, let's say instead of that, you put in $50 every month. Now you have what's called an annuity problem because you're adding in more money as well as earning interest on whatever was in there already. So things are going to add up faster. So you're going to need a new formula. Now, let's define what an annuity is. So an annuity is just a sum of money that's paid in regular increments. Usually we're talking about like a loan paid every month. Something like a student loan, a mortgage, things like that. It could also be like in this example where you're putting the same amount into a savings account every single month. And the formulas for it is going to be A times R plus this times this whole fraction. So here A is the total sum of the annuity. R is what's called the periodic rent, which you can see we've got defined down here as just the regular payment. So in this case, the $50 or whatever your monthly amount would be. I is your interest rate, and then N is the number of payments total. It's a little short on space. Now, so what I'll do with any formula is I'm going to start out by just identifying what all these variables are. So in number 1, we've got our $50 in savings account deposited every month. So that means that that's our R is 50. Our interest rate is 2% compounded monthly. And so just like with compound interest, we're then going to divide that 2% interest rate over each month, so that our interest ends up actually being 0.02 over 12 when we plug it in. And then our N, the number of times it's compounded, well, it's 1 time per month for 10 years. So it'd be the 10 years times 12, which equals 120. So these are our numbers, and we're going to find how much we're going to have in total, which is A. Sorry to erase things to make some space. Now let's plug into our formula. Our total amount that we're looking for is equal to R, 50, times fraction 1 plus 0.02 over 12 to the 120 minus 1 over 0.02 divided by 12. Hopefully this is very clearly a calculator problem with an exponent like that. And we'll plug everything in, and we'll end up with the total value being $6,635.98. So you can check that on your calculator. Please pause the video. Make sure that you can get that correct answer. And for those of you who are interested, you'll notice that this is then by interest. 50 times the 120, which you put in yourself, you also earned $635.98 in interest. So that's how you'd use the formula. Let's look at another type of problem. All right, so here we're looking, you want to have $500,000 in your retirement account when you're 65 years old. How much do you need to invest in? All right, so here we have, in this case, we have the total amount we want at the end. So if we're assigning our variables, we know that we want to have $500,000 when we retire. We know that we have, we want to invest in the account each month, and we have 7% annually. And then we want to start when we're 20 years old. So our interest rate is 7%, so 0.07, and then we are converting it into each month because that's how much we're putting in, and that's the time frame we're looking at. And then for our N, we have our monthly payments, so 12 times the number that we're going to make in between our ages of 65 and 20. So we're going to end up making, in this problem, 540 payments into our retirement account. So, and we can see here how much do we need to put in, so we are solving for R. So then we have, here's our formula with everything plugged in except for R. Obviously we're going to type this big chunk into our calculator first, and we're going to end up with, so then we end up with 3,792 for that whole big thing, divided over, and we get the R by itself. So you would need to invest $131.84 a month to end up with $500,000 in the retirement account. So if we look further in the problem number 3, it says, what if you just don't start saving until you're 40 years old? So the only thing that's changing here in this whole problem is that our N value, instead of saving from 20 years old to 65 years old, we're just going to start saving at 40. So replace that. And the only thing that changes then is our N value, instead of 540, is 300. So similarly, we end up with plugging it into our big fraction, 1 plus 0.07 over 12 to the 300, whoop, dropped a 0 there, make sure we keep that, minus 1 over 0.07 over 12, and when we solve it the same way, we end up with, I'll write it up here, R is equal to $617.23. So we can see that there's a huge difference made in just that 20 years put off before you start saving. So make of that what you will. So our last type of problem that we can run into is present value. And the idea here is that you know how much you can pay in your periodic rent, you know how long you want to pay it over with the interest rate. The question is, how much then can you borrow? What is the amount of the loan that you can take? So in this case, that's called the present value, which maybe you remember from our compound interest problems. And that's the amount that you can invest or borrow now if you know that this is the amount that you can pay each month. And it has a very similar formula versus the end value of the annuity. It's just that we see a lot of things in their inverse. So the present rate, A sub P, is equal to R times, in this case, 1 minus I to the negative N over I. So, but we'll follow the same basic thing. We'll look here, we can say, $200 per month, that's going to be your rent, your periodic rent. And we know that we have the loan for 7 years at an 8.5% interest rate, so 0.085, compounded semi-annually. And so then we're going to still turn that into monthly, because we are paying per month, but we're also going to deal with the semi-annually. I think your book is nicer and doesn't make you do 2 different time frames. But I'm making life harder for you and me in this problem, but I don't think you have to worry about it in the homework. So you got over 2 and over 12. So you end up with 0.085 over 24. And then your N, you're making monthly payments for 7 years. So 12 times 7, which is 84 total payments on this car. So we can plug everything into the formula. Sorry, the handwriting gets a little small there. When you plug that all into your calculator, you end up with that the present rate, the amount that you can borrow to spend on your car, is $76,077.15. So let me know if you have any comments or questions here in Google Classroom, on YouTube, or on Zoom. I'll talk to y'all later.